Identify the chemical species and their roles in the equilibrium system. Look at the provided reversible reaction equation. Hx plus y to the power negative is in equilibrium with Hy plus x to the power negative quad Hx acts as the Bronsted-Lowry acid, proton donor, on the reactant side. Y to the power negative acts as the Bronsted-Lowry base, proton acceptor, on the reactant side. Hy acts as the conjugate acid, proton donor, on the product side. X to the power negative acts as the conjugate base, proton acceptor, on the product side. Analyze the thermodynamic equilibrium constant. Keq. We are given that Keq greater than 1. A value of Keq greater than 1 indicates that the forward reaction is thermodynamically favored, meaning that at equilibrium, the products, Hy and x to the power negative, exist in higher concentrations than the reactants, Hx and y to the power negative. Apply the principle of competitive acid-base strength. An acid-base equilibrium always shifts to favor the side containing the weaker acid and weaker base because the stronger acid and stronger base react more effectively to neutralize each other. Since the products are favored, Keq greater than 1, the reactants must be stronger than their corresponding products. The reactant acid, Hx, is stronger than the product conjugate acid, Hx greater than Hy in acid strength. The reactant base, y to the power negative, is stronger than the product conjugate base, x to the power negative y to the power negative greater than x to the power negative in base strength. Compare the base strengths directly. The two bases in this reaction are y to the power negative and x to the power negative. Since the equilibrium lies to the right, the base y to the power negative is more effective at accepting protons than x to the power negative. This mathematically and conceptually establishes that y to the power negative is a stronger base than x to the power negative. Conclude which species is the strongest base overall. Because y to the power negative is a stronger base than x to the power negative, and because Hx and Hy act as proton-donating acids rather than bases in this system, y to the power negative is the strongest base among all the listed species, making option B the correct answer. The correct answer is option B, Y-.